everyone, it's Justin again. In this video, we're going to be learning how to deduce the equation of a line on a graph. In the last video, we were given an equation, which deconstructed into its pieces and then used those pieces to graph it. This time, we're basically reversing the steps. First, we're going to look at the graph and find the y-intercept, or the point where the line crosses the y-axis. Then we'll be using any 2 points on the line to find the rise and the run, which we can then put together to form the slope. Finally, put the slope and the y-intercept where they go into slope-intercept form. Y equals mx plus b. So let's try it. First, we need to locate the y-intercept of this line. This line crosses the y-axis at positive 1, so the y-intercept is 0, 1. Now we need 2 points to find the slope. We already have 1 point, the y-intercept, so let's use that and this point right here. Between these 2 points, the rise is 1 and the run is 3. So the slope, rise over run, is 1 over 3. Now we have everything we need to write the equation for this line. The general equation of the slope-intercept form is y equals mx plus b. We place the slope, 1 over 3, in the place of m, and the y-intercept, 1, in the place of b. And there's our equation. This is the line y equals 1/3 x plus 1. Here's another example. First, we find where the line crosses the y-axis, which is right here at 0, -2. Then we use 2 points to find the rise over run. Between these 2 points, instead of rising, it falls 4 units and runs only 1 to the right. So the slope will be -4 over 1, or just -4. Now we can plug it into slope-intercept form, and we get y equals -4x plus -2. But we can rewrite plus and negative as subtraction. So the equation of the line is y equals -4x minus 2. Here's our next line. Maybe you remember something from a previous lesson about this kind of line. Let's find the equation. It crosses the y-axis at 4, so the y-intercept is 0, 4. Next, we need to find the slope. Between these 2 points, it doesn't rise at all, so 0. It runs 2 units, so our slope will be 0 over, 0 divided by anything is 0, so the slope is 0. We plug it into slope-intercept form. 0 times anything always zeroes out. So we end up with just y equals 4. If we take a close look at the line, we see that this equation actually makes sense. Even if it looks weird, this is the line made up of all points where the y-coordinate is 4. Be on the lookout for horizontal lines. They'll always have a slope of 0, so the x term disappears, and the equation ends up being y equals some number. One more example. This one's really tricky, but again, you may remember this from earlier in the course. So what's the y-intercept of this line? Well, there isn't one. This line never actually crosses the y-axis, so there isn't a point we can call the y-intercept. Just to be clear, the y-intercept is not 0, 0, because that would still mean it crosses the y-axis. No number, not even 0, meets the requirement. So that's weird, but we'll move on. So let's find the slope. Between these 2 points, it rises 2, and the run is 0 because it never goes to the side. So the slope is 2 over 0, which is not mathematically valid. You can't divide a number by 0. Do you remember the name for this type of slope? If a line is vertical, so trying to find the slope causes you to divide by 0, this is called undefined. So we've got a line here that has no y-intercept, and that slope is undefined. We've got nothing useful to write the equation left. Is there even an equation? Well, of course there is. This line is just impossible to write in slope-intercept form. Here's why. This line is made of all the points where x is -6. So we just call the line x equals -6. It can't be written in slope-intercept form because there's no y for the y equals part. Every vertical line is like this. Vertical lines are the only lines that can't be written in slope-intercept form. So that's all there is to writing equations of lines. Use the graph to find the y-intercept and slope, then insert them into slope-intercept form. Other than vertical lines, this will always work. In the next lesson, we'll be writing equations again, but instead of graphs, we'll be using them to represent word problems.
Hey, hey.